Here we're going to solve by completing the square and using the square root property. Now we have the quadratic 2x squared minus 20x minus 15 equals 0. And this process isn't necessarily the most efficient way to solve this quadratic, but it's going to expose you to some algebra. So to use the square root property, we really need a perfect square involved. And so from algebra, we know that when I have the quantity x squared plus some b times x plus that value of b divided by 2 squared, those three terms factor to a perfect square. They factor to the quantity x plus that b value divided by 2 all squared. So with that in mind, we're going to come over to our quadratic and we're going to try to create this three-term quantity here. Something that looks like x squared plus bx plus b over 2 squared. My leading coefficient over here is a 2 though, and I need it to be a 1 to apply this. So here's what I'm going to start by doing. I'm going to focus on these first two terms right here, 2x squared minus 20x, and I'm going to factor a 2 out of both of them so that I'm going to get my leading coefficient of 1. So if I factor out a 2, I'm left with 1x squared minus 10x. Now remember that if I'm going to try to create this collection of three terms right here, I'm going to need to add at least one term right here with what I'm about to do. So I'm going to leave some space. So I'm going to close my parentheses and leave some space there. And I don't want to forget about this negative 15, or minus 15, I should say. It's just bring that guy on down and put minus 15 equals 0. So at this point, it's the exact same equation, just a little bit rearranged. I factored out a 2 from the first two terms and then moved the negative 15 over a little bit. And I left some space to complete the square, to create this three-term combination. I need to put plus b over 2 squared. Now my value of b in this example is negative 10. So if I take b as negative 10, and then I divide by 2, that's negative 5, and then if I square that, negative 5 squared is 25. So that's the number that I'm going to need to add. So right here inside this set of parentheses, I'm going to add 25. But I just randomly added a number to an equation, and that changes the equation. So I can't just randomly add 25 without balancing things out. So I'm going to also subtract 25 right after I added 25, right there inside the parentheses, because now it's like I've added 0. All right, so now the whole idea is that those three terms are now of the form x squared plus bx plus b over 2 squared, so they factor to quantity x plus b over 2 all squared. These first three terms are going to factor to x and then plus b over 2. Well, b was negative 10. And when we divided by 2, that's negative 5. So it's actually going to be x minus 5 squared. And so that's those first three terms. Well, those first three terms, they're multiplied by 2, so I have to keep the 2. Let's bring that down. But wait, the 2 doesn't just multiply to the first three terms, it multiplies to that fourth term as well. So basically the 2 has to distribute to the negative 25. That's going to be negative 50. Then we'll remember that minus 15 equals 0. So I have 2 times the quantity x minus 5 squared minus 65 equals 0. And from here, we can add the 65 to the other side and divide by 2 on both sides. I can take the square root of both sides, which will leave me with plus or minus the square root of big square root 65 over 2. And then I can add the 5 to the other side. So I have x equals 5 plus or minus the square root of 65 over 2. So of course that's two different answers there. And I'm just going to leave it like that. I'm not going to bother rationalizing because this was more to practice this technique of completing the square so that we could create again, something that allows us to apply that square root property to solve the quadratic.